So before we start doing some problems, I kind of wanted to show you guys a little bit of how this TI-36X Pro kind of works with. The first thing that you kind of want to notice is you have your sine, your cosine, and your tangent in there. So this will give you the angle, so you don't have to be doing the 30, 60, 90 and the 45, 45, 90 all the time. You can just use these tools. Now, one of the things that you always want to be very careful with is your mode. So you click on your mode, and you'll see on the first one that it gives you degrees and radians. So depending on what you're looking at, make sure that you're in the appropriate settings. So if you're on radians, then it'll give you the things in radians. If you're in degrees, then it'll accept everything in degrees. Okay, so for the most part, most of the problems that we're going to be doing is in, at least for the word problems, are going to be in degrees, but there's going to be times where you need to figure out something in radians, so you can go to the radians. Okay, so the way that you can do that is that you can immediately do the sine of 60 degrees, which is just basically what we did. And then you can see that it's going to be square root of 3 over 2. So it does that. So it gives you the exact answer. What I do not want to see on the exam is this. I do not want to see that. Okay? I want to make sure that I get the exact answer. I don't want the approximate answer. That's why I want you guys to invest yourself in this type of calculator, because this calculator will make it like that. If you're doing the graphing calculator, it's not going to give you the correct answer, and I'm going to mark it wrong. So make sure that you do the exact answers as well, okay? And even if you don't have this calculator, you can still do it using the 30, 60, 90 and the 45, 45, 90 triangles, okay? So it does that. Now, in addition to that, be very careful, because if your calculator is in radians, and let's say you wanted to calculate the sine of 60 degrees, well, it's not going to give you that. It's going to give you something completely different, because it's thinking that it's 60 radians, not 60 degrees. So you want to make sure that you go into your, if you ever think that, hey, you know, that problem sounds kind of wrong, go to your mode and make sure that it's in the appropriate settings. Same thing when you're in your physics classes, and then if you're going to be taking chemistry, and if you do some sort of degrees or something, or some trig functions, make sure that you're in the correct setting. Okay. One more thing, if you wanted to take, let's say, the cosine of 45 degrees, you got this. Let's say you really wanted the approximation answer. All you got to do is press a button right above it, which is going to be the approximation sign. It'll give you the approximation as well. Okay, so if at any time you want to give an approximation, that's how you kind of do it. So you have other different tools. Later on, we're going to do inverses. So by pressing the sign twice, you're going to get an inverse. We'll talk about what sine inverse means later on. Not for a while, but yeah, just they're really, really useful. If you ever want to do cotangent or cosecant, they're not there. But one thing that you can do is that, because we know that well, let's just wait until later when we talk about identities, and I'll show you what cosecant and cotangent are in the calculator. Okay, so that's kind of what I wanted to show you before we start doing some of the word problems. So let's do some of these problems. So I won't have my calculator up there, but you'll have your calculator on your own. So make sure that everything is in degrees. And then we're going to be putting them on the calculator. So, okay, so here we have, to find the height of a tree, a person stands to a point 30 feet from the base of the tree. Okay, she measures an angle 57 degrees between a line of sight to the top of the tree and the ground. So find the height of the tree. So we know that we have a tree. Okay, so let's start off by drawing a tree. So here's my tree. All right, so a person walks to a point 30 feet from the base. Okay, so this person is walking 30 feet, okay, from its base. She measures an angle of 57 degrees. Okay, so measures from a line of sight to the top of the tree. So to the top of the tree to this line of sight, she measures a 57 degree angle. Okay, and what we want to figure out is find the height of the tree. So we want to see how high is this particular tree. okay, the height. So you can kind of see that we created a triangle here. So now one of the things that we have to think about is how can we relate this angle with the height and the bottom. Okay, so you can see that this is kind of like the opposite over the adjacent. So this is actually the tangent. So the tangent of 57 degrees is going to be equal to h over 30. Okay, so we got to solve for h. So let's multiply by 30 to the other side. Multiply by 30. So that's going to go away. So we're left with h is equal to 30 tangent of 57 degrees. Make sure that you do not multiply the 30 by the 57. That's wrong. So in your calculator, go to your calculator, put 30, and then multiply it by the tangent of 57 degrees. Okay, you don't need to write the degree symbol. You just write 57. Okay, and what you're going to get, so let's round this to 2 decimal places. Let's say this is going to be 46.2. And in this case, this is going to be in feet. Okay, so that's how tall this tree is, 46.2 feet. 46.2 feet. Okay, so if you didn't get this answer, make sure that you check whether you're in radians or degrees, because that might be the number one issue. Okay, so now let's do this next problem. So from the top of a 100 meter high lighthouse, the angle of depression to a ship in the ocean is 28 degrees. How far is the ship from the base of the lighthouse? Okay, so we have the top of the lighthouse. So here we are. So we're at a lighthouse. Let's just imagine that this is the lighthouse. So here I am. Okay, so the top of the lighthouse, maybe you're right there. The angle of depression to the ship in the ocean is 28 degrees. Okay, so from here all the way to a particular ship, so let's say the ship is there, is 28 degrees. Now we have to be very careful because it's not this, it's from the horizontal. So what I like to do is I like to draw a horizontal line whenever we're talking about the depression. And now what we're gonna do is we're gonna take the angle of depression, which now in this case is going to be this guy. This guy is the angle of depression, not the other one is. Remember, that's always a tricky one. So this is going to be 28 degrees. Okay, so what we want to know is how far is a ship from the base of the lighthouse. Okay, so we want to know this guy. How far is this guy? Okay, let me make it a little nicer. Okay, so one of the things that you have to be very careful with is that we're looking for this height. Okay, this is the height that we're looking at. Okay, or maybe I shouldn't say height, maybe I should say base. So we want to know how far the base of the lighthouse, so here's the base, to the ship is. So we want to know this x value. So how can we figure this out? Well, there's many different ways that you can do it. One way to kind of think about is that these are just basically a square, a 90 degree, and you have 90 degree angles. We also know that this is 100 meters, right? So I know that if this is 100 meters, then I know that this guy should also be 100 meters, okay? Because I know that this is x, this bottom part is x, that means that the top one should also be x. Okay, so basically solving for this bottom part is the same thing as solving for the top part. So all I gotta do, notice that these are 90 degree angles. All I can just do is just use a trig function. So here, this 28 degrees is opposite over the adjacent. So I'm gonna use tangent again. The opposite is 100 over x. Okay. So now all I'm going to do is I'm going to multiply the x to the other side. I'm going to multiply by x. This goes away, so I have x tangent of 28 degrees is equal to 100. And now I'm going to divide by this tangent, because this is just a number that I'm going to put in the calculator. So I have x is equal to, let's approximately say that, so it's going to be 100 divided by the tangent of 28 degrees. That's going to give me 188.07. And this is, in this case, it's meters. Okay. Okay, another way that you could have done this problem is that you can see that this entire thing, so this whole thing is a 90-degree angle. So if this is 28 degrees and I take 90, okay, well, let's find the supplementary angle of that. Well, we know that this guy is just going to be 62 degrees, okay? And then from 62, we can actually just find this guy, the opposite over this adjacent side. So you can actually do the tangent of 62 degrees is equal to x over 100 and move the 100 over and go ahead and put 100 times tangent of 62 degrees. That actually is going to give you exactly the same thing. So if I do x is equal to 100 tangent of 62 degrees, you're going to get exactly the same answer, 188.07. Okay, so you'll still get exactly the same answer. Okay, now let's do this last problem that's a little bit more complicated. Okay, so put a star next to this, okay, because it's really important. So here we have, from the top of a 20-meter high castle wall, the angle of depression to a knight in the field is 16 degrees. So the knight rides directly toward the wall with the angle of depression until the angle of depression is 50 degrees. So how far did the knight ride? Okay, so let's first start off by drawing a picture. So let's start off with drawing the 20-meter high castle wall. So we have this castle wall. Let's just say that's a castle. It's 20 meters high. And you have the angle of depression of the knight to a knight on the field is 16 degrees. So if you're here and then you have a knight right there, that's 16 degrees. So let's start off by drawing the horizontal line again to kind of just give us a little glimpse. So we know that this guy right here, the angle of depression is going to be 16 degrees. Okay, so we have that. So that's the angle of depression. So the knight rides directly toward the wall. Okay, so the knight is heading towards us. Okay, toward the wall. It's heading there until my angle of depression is 50 degrees. So now, from here to here, this guy right here, so now it's right here, this whole angle now is 50 degrees. Okay? So what we want to figure out is how far, so let me just keep drawing this. So we want to figure out how far did the knight ride? Okay? So in other words, how far is this guy? We're going to call it x. Okay, so I want to know what that guy is. Okay, so here we have to use a little bit of geometry. Okay, we really have to be very, very careful with all of this. Okay, so I want to be able to think about your geometry very well. How can I figure out what that x value is going to be? Well, one thing that I see is that I see this big triangle right here. I see this one. Let me make it a little bit more smudgier. So I see this big triangle right here. So I see this big triangle and I think about, well, why don't I try to figure out what this distance is? The entire distance. Okay, let's just say that's D1. Let's try to figure out what that guy is. Okay. Now, in order for me to find what D1 is, well, I need to figure out what this angle is. Let me make it a little bit more smudgier. I need to figure out what this angle is. Okay. Well, if you look at this, you have the red angle right here. Here's your red one, which is 16 degrees. We know that these are going to be 90-degree angles. So this guy is just going to be 90 minus 16. So we're going to take 90 minus 16. That's going to give me 74. Okay. So this guy is going to give me 74 degrees right there. Okay, so that's that one. All right, so let me make it a little bit over here. Okay, 74. Okay, so now all we got to do to figure out this D1, this big distance, is just, well, that's going to be the opposite over the adjacent. So that guy is just going to be the tangent. So the tangent of 74 degrees is equal to d1 over 20. Okay, so I'm going to move the 20 over. 20 tangent of 74 degrees is equal to d1. So d1, which is that big distance, is going to be 20. Then the tangent of 74 degrees, that's going to give me 69.7. Okay, so this big D is going to be, D1 is going to be 69.7. Okay, so that's that guy. All right, so I got that guy. Now, if I were to want to figure out x, well, one way that I can do it is to try to figure out what this little distance is. So you see that there's another right triangle here. So let me make it, I don't know, purple. Let me smudge it a little bit. So you can see that you have another triangle right here. Okay, so we have that triangle. Okay, so now what is this angle right here? Well, if you see, we have that 50 over there. 50 was the other part, so what's going to be the other side? So I'm going to take 90 minus 50, that's going to give me 40. 40 degrees. Okay, so now what I want to figure out is try to figure out what is this D2 going to be? Okay, so again, we're going to use tangent. So I'm going to have the tangent of 40 degrees is equal to D2 over 20. I'm going to move the 20 over. Tangent of 40 degrees is equal to D2. So D2 is equal to the 20 tangent of 40 degrees, which is going to give me 16.8. This is going to be meters. They're all meters. Okay. All right, cool. All right, so we have that, but that's not quite the answer, because how am I going to figure out what x is? This is what I'm looking for. Well, I know the entire distance. I know the distance of this small one, so if I subtract this guy and this guy, I'm going to get my x. So x is going to be equal to d1, which is the total distance, minus the smaller distance, d2. Okay, so d1 in this case was 69.7. I'm going to subtract it, 16.8. I'm going to take 69.7, subtract 16.8, and what I'm going to get is 52.9, and this is meters. So this is how much this knight traveled. Okay, so this problem was a lot more involved, but it's a really good problem. Make sure that you really understand how to do this problem. Okay, and if you didn't, just watch it over and over again until you finally understand it.